I'm now going to go over 2014 adapted decision question 4 on critical path analysis. The first question asks us for the definition of the total float. Well, simply the total float is the sum of the float on all the activities, where float on any activity is the spare time you have to complete that activity, such that it wouldn't delay the overall time of completing the project. Okay, next thing it asks us to do is complete the activity network. Just do that now. We'll start for naught, and we're going to complete the forward scan. Remember, with the forward scan, we're just looking at the top boxes, and if you've got a choice, if you've got more than one activity going into a box, then you pick off the biggest number. So 0 plus 4 is 4. 0, we've got a choice here, so I've either got 4 plus 7 is 11 versus 0 plus 5 is 5. So I'm going to go 4 plus 7 is 11 because that's bigger. Here 4 plus 9 is 13. A choice for the next one, 4 plus 6 is 10, or 13 plus 2 is 15, so clearly 15 is the bigger one. Here we've got several there, so 11 plus 3 is 14. And then to this box, we've got 14 plus 0, because this is the dummy, the one with the dotted line. 14 plus 0 is 14. 11 plus 10 is 21. 13 plus 3 is 16. 15 plus 4 is 19. So 11 plus 10 is 21 was the biggest. Down here, 14 plus 2 is 16. 16 plus 0 is 16. 14 plus 5 is 19. 21 plus 9 is 30. So 30 is going to be the critical time, the minimum time you can complete the project. Now, slightly different to the way the textbook does this, we're going to now do the critical path, because that will knock out loads of the bottom numbers straight away. So now here we're going backwards, where we're trying to see no gap in the subtraction. So for example, 30 take away 5 is not 14, but 30 take away 9 is 21. Remember, there can be more than one critical path, so just be careful. Look for it for your forward scan when you add two numbers that added up to make the same, to give you that number. So 21 take 10 is 11. If you look at the others, 21 take 4, no, not 15. 21 take 3, no, not 13. 11 take 5, no. 11 take 7 is 4. 4 take 4 is 0. So that gives us that critical path. Now the benefit of that is, along the critical path, you're going to have the same number top and bottom. So immediately I know all of these, which saves me a lot of time. To fill in the remaining late event times, the bottom numbers, I do the back scan. This is where you're going backwards, only using the bottom numbers, subtracting. And again, if you've got a choice, you've got more than one activity going against the arrows into a box, you pick up the smallest number this time. Forward scan, biggest number. Back scan, smallest number. Here I've got 30 take away 0, because this is a dummy, remember, it's 30. 30 take away 2 is 28, but oh look, I've got a choice here, so I've got 28. 30 take away 5 is 25. 21 take 0 is 21. So of all those choices, 21 is the smallest. This one, I'll do this one first. 21 take away 4 is 17. 17 take 2 is 15, or 21 take 3 is 18. So the smallest of those choices is 17 take 2 is 15. And that is all of them. State the critical activities. Well, the critical activities are those along the critical path. So that's A, C, A, C, J, M, and that's our critical path. Calculate the maximum number of days by G could be delayed without affecting the shortest possible completion of time of the project. Well, that's effectively asking us for the float of G. Now, when you're looking at activity G, you're only looking at the top number at the start, the early time, to the late time. So it's only these boxes that have got anything to do with G. This 11 is to do with these activities. This 14 is to do with these activities. So we'll just go from top to bottom. And then float's calculated by bottom, take middle, take top. So late time, take activity time, take away early time. So what's this do? So if we do 21, take away 3, take away 11, what's it going to be? 7. So that means G has a float of 7, so you've got 7 hours, or is it days? Oh, I can't see in the question where it says days, or whatever it is, days or hours, but you've got 7 units of time to play around with. So basically this means the early time 11, so you can't start till, let's call it day 11. You must end by day 21, so you've got 10 days to play around with, but it only takes you 3 days. So you've got 7 hours of spare, so you can like get away with starting this on day 18 if you need to, or you can start it on day 11, finish at day 14, and then you've got 7 hours or days, whatever they are, spare at the end when you've completed it. E. Calculate the lower bound for number of workers needed to complete the project in the minimum number of time. Now there are 2 ways of doing this. You either add up all the event times, which is a pain in the backside, but it's easy, and then divide by the critical time, or you can do it on the Gantt chart. Now because it's asked me to do this before I've even drawn a Gantt chart, I also need to do it using the first method. But read the question carefully, because if it wants you to use a Gantt chart and asks you to use a Gantt chart, you must use a Gantt chart, or you're going to lose marks. So E. Well, it's a bit of a pain, but what I need to do is add up all the times. Now, I'd suggest doing this alphabetical order, do it from left to right, but do it twice because it is easy to get wrong. And then again, if you're not sure, just do it on your calculator. If we go at 4, I'll just put dot by them now. I've done them 4, 9, 16, 25, 31, 33, 36, 39, 43, 53, 58, 60, 69. Just check I've got a dot by all of them. I think so. So that's 69 divided by 30, which is 2 9/30. So 3/10, that's 2.3. So if you round that up, that means we're going to need 3 workers. It's the minimum number of workers to complete it by 30 days or 30 hours, wherever that is. It then says the project to complete in minimum time using as few workers as possible. Scheduled activities. Now schedule is year 2. So if you come across any of these questions preparing for the year 1 exam, instead of scheduling it, just draw a Gantt chart for extra practice. Drawing a Gantt chart is good fun. So first thing to do on a Gantt chart, first thing to do on a Gantt chart is to put on the critical path on the top row. Note it goes up to 34, that's deliberate in case you've manked this up. So it'll give the game away if this was 30 and it ended at 30. And if you did get above 30, we know what's going on. So I need a box that goes all the way across to 30. And we really should use a ruler as well. Another tip is with your ruler, line it up like this as well, so you make sure that you don't make anything up. So A was 4, B was, no, not C. C goes up to 11. And then I went across J, which took me to 21. And then finally M, which took you from 21 to 30. In the next row, you should normally put in the critical activities that weren't used in your critical path. There aren't any in this question. So what I'm going to do now is put all the remaining activities in alphabetical order. So just put a list down the side so you don't miss any out. So A, B, C, D, E, F, G, H, I, J, K, L, M, N. There wasn't an N. If you've just got a lot of them and it goes up to say P or Q, don't spend ages looking for O. There won't be an O. They'll always skip O because it looks like 0. Well, I think that's why they skip it anyway. Now each of these should be done in order and have a new line each. Just because B and E and F can all fit on the same lines, same row, don't do it, put them on separate lines. You want your answer to replicate as near as possible the mark scheme. So B, so if I find B, where is B? Here's B. So remember, it's top to bottom. So I need a box that goes from 0 to 11. And again, I really should be using a ruler to do this. B takes five days, or wherever we said it was. 1, 2, 3, 4, 5. And then shade off the rest. And that's actually B's float. So B's got, wherever there's 6 boxes, 6 days, 6 hours, wherever it is, a float, 6 hours to play around with. D, 4 to 15. This is where you might need to line up. D is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's got 2 float. E, where's E? E's here, 4 to 17. 6, 1, 2, 3, 4, 5, 6. And just shade off the float. F, 13 to 17. Just a little 1 for that. Takes 2. G, where is G? Oh, G. No, it's here. 11 to 21. 11 to 21 takes 3. H, 13 to 21. H takes 3 as well. I, where's I? I's there. 15 to 21. 4. Just has 2 floats. I, K, 14 to 30. That's 5. And then finally L, again 14 to 30. And just takes 2. You can see you've got a lot of float. So when it talks about in part A total float, it would be all of these boxes added together, which is quite a lot for a project. Now, it's not part of this question, but if you remember, I talked about the lower bound before, and if you wanted to work out a lower bound from a Gantt chart, what you're trying to do here is pick a time where you've got more critical activities to that time that are occurring. So what we do is you find a line where you're hitting a lot of activities. So for example here, if I did a line here, no, actually I'll do it here. Now remember, this is day 1, this is day 2, this is day 3. So this line I've drawn here is day 10. So on day 10, C is a critical activity, or critical to that time. Right, so we often say must or may be occurring. So activity C must occur. If it doesn't occur on day 10, you're going to delay the whole project. D must occur. So what you can do with the Gantt chart is try and slide out the way of that line. But I haven't got enough space. That's the latest I can start it. So no matter how much I slide this activity into the spare amount of time, I can't escape this line. So D also must occur. E though, I have got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If you look, you can slide E all the way to the right and it will escape this line. So E may occur. So must occur, may occur. So on day 10, you're definitely going to need 2 workers. But can I pick a line where I'm going to hit more than that? Well, and usually on a lot of these, you've got a lot of spare float, so it's easy to move them out of the way of the line. So I'm not even going to bother with those. So here, I'm only going to get 2 here as well. Now, one of the reasons it hasn't asked us to do this question is because it's more complicated, because, say for example, I've said here, on day 10, I only need 2 workers, but that pushes E over to here, which means if I draw a line here, I'm now hitting more than 2 workers, so I can improve it to over 2 workers to 3. So it's not a very good example of how to use a Gantt chart to find the lower bound, because I can't draw an individual line and get more than 2 workers from what I can see. I can't. So it would be 3 workers because of the fact of if you push one activity from a time into another time, it's going to have to be one place or the other. It can't be in either of them. So you're going to have to do it by doing more than one line, which is complicated and very, very rarely asked. I think I've only ever seen it asked once. Okay, anyway, that will end that question there.